Welcome everyone to this Hubble 30th anniversary event. We're super glad to have you here to have an hour of fun space talks. So to begin, I'd like to introduce you a bit more about our speakers. Here we go. Oh, sorry. So first of all, a bit more about, there's been a bit of, just a second. Okay, so here we go. So let's talk a bit more about our sponsors. So we're super glad to propose this event thanks to the Swiss Space Center, which is represented here by Claude Nicollier, and the EPFL Space Center and the Laboratory of Astrophysics, represented by Jean-Paul Kneib here with us. Also, a special thanks to the EPFL Library and the European Space Agency for helping us to launch this extraordinary event to celebrate Hubble today. So if you're interested about Hubble, we'll have also next semester a special event on campus, hopefully, and an exposition at the Rolex at TPFL as well. And also would like to thank you guys for being here and celebrating Hubble with us. It is such a pleasure to be with you, and even if it's online, it's great to see that Hubble has such a strong family here on Earth. So to introduce you a bit more about our mission at Space at Your Service, we are a nonprofit organization which aims at promoting and rigorizing space sciences, but also we are the organizers of Astronomy on Tap Lausanne. If you don't know what it is basically events that we organize in bars around Lausanne. And we also have a special focus on SciComm production and escape rooms. And we are also the main organizers of the Asclepios mission. So go take a look at our social media. So you can find us on Facebook, Instagram, Twitter, LinkedIn, and YouTube. Well, YouTube you already know. Other reason to do that is to find the Hubble test. So we've prepared a special game for you today. So if you want to test your knowledge about Hubble, go on Facebook or on our YouTube chats, and you can test it throughout this hour. And we'll give you the answers at the end of the talks. So in about an hour and a half. So astrophysics, what is it and what to expect? So usually when we talk about astrophysicists, we have these expectations of Sheldons and uncool people, but we like to organize events to show you that astrophysicists and scientists are actually very, very cool. And to do so, we're going to talk about Hubble Space Telescope today. So we'll be celebrating Hubble 30 years. I'm not going to talk so much about Hubble because we have two amazing men here to talk about it in more depth. But basically, it's one of the wonders of the sky, even though it's a human invention. And it orbits at 590 kilometers above the ground and transmits about 120 giga-octa images each day to Earth. It was put into orbit on April 24th, 1990 by the Space Shuttle Discovery. And among the astronauts that have gone to Hubble are Swiss astronaut Claude Nicollier, who is here today. And also we have the observation of the solar system and into the depth of the universe done by this amazing telescope. So today we'll have, first of all, a 10-minute talk by Swiss astronaut Claude Nicollier, followed by the astrophysicist Jean-Paul Kneib, who has worked on Hubble as well. At 1 or 1:05, since we've had a bit of technical difficulties, we have the reveal of Hubble 30 image. And then we'll follow with a panel and a Q&A and answers to the quiz. So Claude, if you want to share your screen, you can do so. And if you can unmute as well if you want. Well, it's better.
Okay, do you see my presentation now?
No, we can only see you for now.
Okay, hold on 1 second. Hold on. So I don't have the presentation shared with you?
Not yet.
Okay, hold on. 1 second.
Ah, perfect. We can see now.
How about now?
Yes, we can see.
Oops, hold on. Give me another 15 seconds, then I will be okay. Okay, how about now?
Yeah, amazing. We go for lunch.
Okay, well, it's thank you very much, Chloe, on one hand for your introduction and for organizing this event. It's a great pleasure to be able to talk about Hubble. It's a great anniversary of a unbelievable discovery machine, which Hubble has been, is, and will be. I'll talk about the telescope, the launch, the installation on orbit, and the servicing missions, because I had a huge privilege as an ESA astronaut to go twice to visit Hubble on the first servicing mission in December 93, and the third one 6 years later in December 99. And I'll talk about telescope and servicing, a little bit about the first astronomical results. And Jean-Paul Kneib will talk about more recent discoveries and work, including work that he has been doing recently using the data from Hubble. All right, so the launch was 30 years ago. April the 24th, 1990 was the launch of the space shuttle from Kennedy Space Center, Florida, to put the telescope in orbit. Light up on the three main engines of the shuttle and then the solid rocket boosters to boost the telescope into orbit. Beautiful sight, always very impressive. We had 5 crew members on board: Lawrence Schreiber, the commander, Charlie Bolden, the pilot, Steve Hawley, Kathy Sullivan, and Bruce McCandless. It's amazing to see the shuttle going through the clouds. Hopefully it will get on the other side without. Yes, it does. Okay, so this is launch Hubble. I will shorten it because we are short on time. But anyway, it's 8.5 minutes ascent to orbit. And then the day after, Hubble was deployed from the payload bay. And you see here the deployment from the payload bay using the robot arm controlled by Steve Hawley. You see the payload bay of the shuttle, the wings, the Earth below, 600 kilometers below. And the telescope, which was filling the whole payload bay, is being deployed with the robot arm. A very nice picture of the release on the orbit of Hubble, 600 kilometers altitude, the inclination of the orbit 28.5 degrees, so relatively close to the equator. And you see the cover of the optical system. Whenever the telescope was close to the shuttle, the cover was always closed in order to avoid any contamination of the optics by the cloud of gas with a thruster system for control of the attitude of the orbiter. And as you know, a few weeks later, it was discovered that we had a problem. On the left, you see the picture of a star on one of the scientific instruments, as was expected. And what we had was what you see on the right. We had a significant spherical aberration because the primary mirror, 2.4 meter in diameter, had not been figured properly. That was a huge problem, and it was a nightmare for NASA. I was at the Johnson Space Center already at that time, training for my first mission, which was in 1992, 2 years later. And it was a nightmare for NASA. It was a dream for cartoonists. You see here a representation of the Hubble Space Telescope optical design group. They don't look like very smart people. They are not even able to put the placard with their right orientation. Anyway, it was a difficult time for NASA, but the idea was to recover Hubble, to make it usable, design an optical corrector that was going to be installed on the first servicing mission planned for December 93, three and a half years after the launch of Hubble. And these are all the servicing missions that have been accomplished. It was planned from the beginning on to go and visit Hubble every now and then to do repair if needed or to improve the scientific instrument. And I was, again, very privileged to be part of the first mission, SM1, in December 93, and the third one with the spacewalk in December 99. And here we go. First servicing mission. For the first time, we met with the telescope. It was my responsibility to do the grapple with the robot arm. You see the end of the robot arm on the right-hand side of the picture. Installation in the cargo bay. And here we are, the cargo bay toward the Earth. We have the island of Madagascar on the upper left, and you see the telescope quite large. It's about 15 meters high, 4.5-meter diameter for the lowest section. And you see the solar array, the old solar array, which had to be exchanged. They were not in very good condition. We did 5 spacewalks, amazing spacewalks, very much trained, exercised during more than a year training that we had a so-called mission-specific training for this first visit to Hubble. You see here on one of the spacewalk when we exchanged the solar rays, you have Story Musgrave at the end of the robot arm that I was commanding. And on the far right in the payload bay, Jeff Hoffman. The spacewalks were always 2 people at a time. And this was 2 important spacewalks. You see me on the upper left commanding the robot arm. And on the lower left, you see the installation of Wide Field and Planetary Camera number 2, which has become a major instrument from that time on until it was replaced with a Wide Field Camera number 3 in 2009. So for a long time, it was a major instrument on Hubble. And on the middle and on the right, you see the installation of COSTAR, corrective optics, space telescope, axial replacement to do the correction of the optics for the axial instruments. With Katie Thornton holding this optical corrector, big box like a telephone booth, and Tom Akers in the lower left. We had success on this mission. This is shortly before the deploy of Hubble. The whole crew members, Dick Cavey, the commander, Jeff Hoffman, Ken Bowersox, Tom Akers, Katie Thornton, Story Musgrave holding my right shoulder. We were really happy. We had a total success on this mission. We still didn't know whether the optical corrector was okay. And we got to know this a few weeks later. We had Barbara Mikulski, who was a congresswoman responsible for the relationship between Congress and NASA. She presented an image of Messier 100, the galaxy, before the correction on the left and after the correction on the right. So not only the mission was a success as far as all that we had done during the 11 days of the mission, but the optical correction was perfect. This was a huge relief for many, many, many people, including, of course, the crew itself. Now, I'm not going to talk in detail about the result from Hubble. Jean-Paul will talk about that later, but there are a few images that were obtained during the year after our first servicing mission. So it was in 1994 and in 1995. And I remember these pictures were very striking for me. And they were extremely rewarding for us crew members, but also the whole team that had planned this servicing mission. And I show on the far left the impact of a comet, Shoemaker-Levy on the surface of Jupiter. This is in the summer of 1994. In the middle, you have the famous picture of the Messier 16, the pillars of creation. And on the far right, you have protoplanetary disk in the Orion Nebula. Amazing picture showing stars in the making and also disk of gas and dust around these stars that in the future will create planetary system around these stars. And an amazing picture and also for us an enormous reward was the first deep field, the idea being to point the telescope in a small region of the sky, typically a few arc minutes by a few arc minutes, so very much smaller than the diameter of the full moon. Basically an area where you have nothing, and after hours or even days of exposure, the first deep field was 10 days exposure. You look at what you have and you have thousands of galaxies. This was an amazing result. The first deep field, there were many more deep fields taken after that, but that was the first one. And again, for me, it brings a lot of emotions when I see this picture. All right, as mentioned, I was privileged to be involved in another servicing mission of Hubble. There was one in between in 96, then in 99, we had servicing mission 3A, this time we had a problem with gyroscopes, and the telescope was no longer able to do proper pointing in the sky. That's training in the water for spacewalk. And here we are, 6 years after the first servicing mission. We are above Australia, 600 kilometers altitude. And I'm at the end of the robot arm installing a new fine guidance sensor. And on the left side of the telescope, yeah, Mike Fall, my colleague, we always do spacewalks, 2 person at a time. And on the side of the fuselage of the shuttle, you see the old fire guidance sensor, which I had removed and will bring it back to Earth. That was an 8-hour-long spacewalk. It was a tough because we had problem with the insertion of that fine guidance sensor, which changed the main computer of Hubble also. And here I say hello from my position in the cargo bay with my spacesuit during this 8-hour spacewalk of the third servicing mission. Now, we released Hubble on Christmas Day, 1999, the 25th of December. And I have to say that I have a lot of attachment and friendship with Hubble. And every time we let the telescope go after servicing, I must say I was a little sad because it was a good friend that you leave it, you fix it, you know, but you let it go. And I have a lot of personal attachment with this magnificent discovery machine. All right, Hubble was then serviced twice since our mission in December 99. It is still very healthy, hugely productive, and will be used for many more years. Happy 30th birthday, Hubble, and over to you, Jean-Paul.
Thank you, Claude.
I will stop my screen share.
Thank you very much, Claude, for this very exciting presentation.
Yeah, very welcome. I don't know how to stop my share, so I'll stop
So
sharing. Here we go.
Yeah, amazing.
Am I successful now?
You are successful.
Over to you, Jean-Paul. Thank you.
Yes, so we now have Jean-Paul Kneib give a talk about Hubble, the scientific side. So Jean-Paul, you can go ahead and share your screen. Perfect.
Okay. So does it work?
Yes.
Wonderful. So it's a pleasure to be here. It's also an old friend for me. I've been working with Hubble data since 1995, sorry. And it's really an amazing telescope. It's a unique system observing the universe from above the atmosphere, which is a very strong limit when you want to observe some stuff in the universe, in particular things that are very distant or very small in size. Hubble has been doing so many things in terms of new discoveries that I don't think it would worth to be listing all the discoveries, but I will focus on some of them. I mean, 2 important discoveries that I won't discuss is the acceleration of the expansion of the universe measured by type 1a supernovae, or the amazing study of the atmosphere of exoplanets. But during the few minutes I have, I will focus on what I call the frontiers seen by Hubble. And so we see Hubble here above the Earth, and of course, you know, it's a distant image, a very long exposure of a massive cluster of galaxies we see here. So I will go about first a bit of explanation and why Hubble is interesting in its properties, in its capacity in observing the universe. Here I'm showing some image of gravitational arcs. Gravitational arcs been discovered from the ground in 1987, and you see a picture on the right, on the left, and you see the same image seen by Hubble right after the repair of Hubble made by Claude, and you see the details that you know, are inaccessible from the ground. You see, you know, dots that turn to be into spiral galaxy. You see very faint objects that are, you know, hardly visible from a ground-based image. So that's the key importance of Hubble. It turns you a 1 megapixel camera into 100 megapixel camera, let's say. So it has the property, because it's above the atmosphere, to see better and sharper the images. So what are those gravitational arcs and how they are made? Oh, too fast here. It's about what we call gravitational lensing. So gravitational lensing is distortion of a background object, a galaxy, by a massive system. The massive system here presented are galaxy clusters. But in fact, any galaxy can take the role of gravitational lensing. And here, what you see is you can have 2 images, or even more, and sometimes 10 or 12 images of the same image. And those images can either be punctual or they can form a nice gravitational arc. So what we do with those? Well, there's many clusters in the universe. Probably easily over the whole sky, more than 20,000 that are very massive. And out of them, we probably know today only like a couple of hundreds. And we study them, and we can see these gravitational lensing effects. And from those effects, from those distortions, from these multiple images, we can basically build up the mass distribution of those systems. And interestingly, when you do the mathematics, the physics of that, what you end up finding is that 80% of the mass of your system is dark matter, 5% of stars, and 15% of hot gas. So really, Hubble has been turning in a machine that can map the dark matter in the universe. This is quite interesting because dark matter has been known or has been postulated for almost 100 years now. And it's the unique way, by looking at the gravitational lensing effect, that we can really map the dark matter in the universe. And there are a future mission, which is called Euclid, that will come in 2 years from now, that will map, using this technique, the mass distribution and the dark matter throughout the universe. When we do this mapping, what we learn is that the mass effectively can be separated in different components. And this is very nicely observed for the bullet cluster, which is a very important observation that was conducted 15 years ago or so, where we see the collision of 2 clusters. And what you see in red is the gas that has been collided and basically slowly interacting, and so it's been slowed. And what you see is dark matter that has detached from the gas. And so it's really one of the best proof of the existence of dark matter. And Hubble was one of the key telescope that was used for this measurement. And we see these spectacular arcs that are also very interesting for another purpose. What you see is, in fact, a tiny galaxy that, because of the amplification effect of the gravitational lensing, make it much larger. So that means you can observe systems that you would not see otherwise. So if you combine Hubble plus this gravitational telescope, this cluster of galaxies, you can see very far away in the universe. So back in 2004, I was involved in a study of the first galaxy at redshift 7, which basically corresponds to a distance of 13 billion light years from us. And it was magnified by a factor of 30. So with Hubble and with the cluster as a telescope, we could basically find those very distant objects. This is not the record. The record came later at redshift 10, also seen by Hubble. And so that means you see a galaxy, 500 million years after Big Bang. So there's been a whole industry with Hubble to look at, the further galaxy away. And there's been, as Claude mentioned, very deep observation, the Hubble deep field, the Hubble ultra deep field, which was even deeper. And more recently, we had also the frontier fields observation, where we were combining deep imaging of Hubble plus the effect of the lensing effect of those cluster of galaxies. But I want to finish by, what's gonna happen in the future. I mean, Hubble is kind of limited to redshift of 10 also just because of the capacity of the instrument. And we need another telescope to go beyond, and that's what we call the James Webb Telescope. And we're probably going to go to redshift of 20 or maybe even 30. And that's going to be a very interesting telescope to be launched next year, hopefully. It's a 6.5 meter telescope, and it will really go very early on to see the first galaxy and possibly the first stars.
Thank you very much, Jean-Paul, for your talk. So if you want to know more about gravitational lensing and what Elastra does, go on their websites or social media, and you'll get excited about gravitational lensing as well. So I guess it's now high time to release the embargo on the anniversary image for Hubble 30. I hope you guys are all ready for this. I'm going to share my screen now very quickly. Okay. As you can guess, the image is pretty heavy, so it takes sometimes a bit of time. Amazing. Okay. So here we go. And here you can find the Hubble 30 anniversary image. Here you can see it better. So now we'll move on to a short panel to discuss a bit more about this image and what it represents. In this video, what I find exciting, and it seems to be in another world, and quite rightly so, I guess, and not only the music, but the images as well. So, and well, you've seen the image, Jean-Paul. Maybe you can tell us a bit more about what is this object and where is it located?
Yeah, sure. So let me share my screen. Have prepared a few slides about the new image. So the object we're looking at is part of the Large Hadron Cloud. So the Large Hadron Cloud is, the nearby small galaxy that is orbiting our Milky Way. And what you see here, so it's the Magic Cloud. And you see plenty of red stuff. So those are basically region where you have what we call H-alpha emission. H-alpha emission is a way to probe hydrogen gas. And so what we see in red is the distribution of the hydrogen clouds. So what the picture that Hubble was revealing is basically this region where we have a nursery of young stars, blue stars, that emit a lot of light, and this light will excite the gas that are between the stars. And this image is not the Hubble image. It's made from the VLT, the Very Large Telescope in Chile. And we can superpose it to the Hubble image. Okay, that's what I'm trying to do now. And let's get rid of the VLT image. And so the specular things you can get with HST is the details. Okay, if I come back to the the ground base image, things are a bit blurry. You see more star because it's more difficult to see faint surface brightness object. So you need to make a very long exposure to see this diffuse image of gas excited by the stars. With Hubble, it's much more easy to do this. And we see two different clouds, let's say, nebulae. We have the blue one at the bottom, which is NGC 2020, and we have the red one, NGC 2014. They're kind of different in the way, well, in their look and in their properties. Let's start maybe from the bottom one. I'll share my screen completely, it's probably better. So NGC 2020 is this blue light. What we see at the center of it is a very blue star. The blue color comes from the oxygen. So what is revealed is the oxygen gas that is surrounding this star. And this star is like our sun, having a solar wind, very strong solar wind, stellar wind, that is pushing the gas away. And that's why it's making like kind of an envelope around the star. So that's for NGC 2020. For NGC 2014, it's a bit more complex. The region is much bigger. And we have a collection of small stars, blue stars that you see in the middle. And here, the gas you see is red, and it's the oxygen. So the blue color comes from, the red color is from the hydrogen gas, and the blue color is from the oxygen. And then, of course, you have a mix of oxygen and hydrogen, and that makes these different color types. And you see also in the red part some very dusty, very black region, and those are filled of dust which are like heavier element, like iron or nitrogen. And it's where it's in this very dark region that you're gonna form new stars. Okay, the blue stars are very young, but this region is a region where there's new stars being formed, and those are embedded in the dust. So I hope it helps in understanding what we see.
Wow, incredible. I guess for people who are not astrophysicists, the first reaction would be, wow, this is beautiful. What would be your first reaction? For you too, when you see this, what are you feeling? Is it just beautiful? Is it something more?
Well, it's beautiful, but it's just impressive in the sense that with the capacity we have with Hubble and with other telescopes, of course, we really are able to see the start of new life, new stars in the universe, and the picture is so crisp, so sharp that you could really imagine to be there, among those amount of gas and dust and see things going. So you can try to make a movie out of things, and so this is really, really impressive.
Thanks. Maybe you can unshare your screen so we can
sure.
do the panel. Perfect. I have the anniversary image in my virtual background if you want to take a look at it again. And how about you, Claude? What about this image? You're on mute. You're on mute.
It's a stunning image in its beauty. And this big nebula, the red one, is like a nest. And inside the nest, you have these blue shades. And Jean-Paul explained the various components, the hydrogen, the oxygen, but it's just a stunningly beautiful image. I'm very impressed. I was showing before the picture of Jupiter and then the Eagle Nebula and then the deep field. It shows the spread of distances that the Hubble covers. We observe objects in the solar system, in the galaxy, and mainly star formation, and a little bit outside the galaxy with a small and large Magellanic Cloud, and then extragalactic objects. So Hubble is able to look at the universe at so different distances and understand phenomena, and it's really stunningly beautiful, and there's so much interesting science behind.
Yeah, of course. So you've mentioned this is in the Magellanic Cloud. So we can't see this Magellanic Cloud from the North Hemisphere, right?
Yeah, you have to be to the Southern Hemisphere.
Okay. Have you seen it?
Yeah, of course. I mean, I spent a few years in Chile, so that's it's also one of the reasons why we're putting, a telescope in the south. It's also a good vantage point to see and look at these two nearby clouds, the small and the large magic clouds, where you have star formation just happening outside of Milky Way. And so it's a very good vantage point.
And how about you, Claude? I know you're an astronaut, but at the beginning you were an astrophysicist, and you still are. So have you been a lot to the South Hemisphere?
Yeah, I've been. In fact, I was on the first mission in 1973 of the Geneva Observatory to La Silla in Chile. It was even before Switzerland became a member of the European Southern Observatory, but we went there with a photometer to do photometry of stars in the 7-color photometric system of Geneva Observatory for the first time in the Southern Hemisphere. We spent about 6 weeks over there, and it was interesting to see that when we worked in the Gornergrat or Jungfraujoch observatories, we had about 1 out of 4 nights that was usable, but over there it was 95% of the night available, so usable. So after 6 weeks of constant work, we were very tired, but we got a lot of data. So this is Chile is a magnificent ground-based place for astrophysics. And I've been there several times since this early trip in 1973. It's always a huge pleasure to be in Chile and of course see the Southern Cross, the region of the center of the galaxy and the Magellanic Cloud. It's a beautiful sky.
Yeah, amazing. Chile is the place to be for astronomers, I guess. And so this object, I think it's located approximately 163,000 light years away from us. So it means light takes 163,000 years to get to this object. But it is actually pretty close compared to other objects that we can see with Hubble telescope, right?
Yeah, sure. And I mean, as I say, we can, with Hubble, go up to like 13.5 or 13.2 billions of years from Earth. So that's quite a scale. And also, I mean, Hubble does also look at our solar system. It's been doing a pretty good image of Saturn, Neptune, Jupiter. It's just an amazing telescope, very versatile.
Yeah, we had even northern lights and southern lights on the big planets, which is quite amazing in the ultraviolet part of the spectrum, so it can't be visible from the ground.
Okay, nice. And if you had to choose like one favorite picture, I know it's hard, but if you had to choose one, which one would it be?
Claude.
Well, I mentioned mine already because, again, after doing the first servicing mission and suddenly opening the universe that was suddenly becoming available thanks to the significant improvement in the optical quality. For me, the first deep field is the image that was brought me the most emotions. And it was 10-day exposure through different filters, not continuous 10 days, but they used 10 days, different filters. And then this very small window in the shape of an L, because there's 3 squares plus a little bit of the planetary camera. And after 10 days in a region where there was nothing, you'd see thousands of galaxies. This was so amazing. For me, it brought enormous emotions. And of course, there were better pictures taken later with the ACS and the wide field camera 3, but still that first one for me is the most amazing result. Historically speaking, with Hubble.
I wish one day I can understand this feeling as well, but not yet. And how about you, Jean-Paul? I know this is hard.
Yeah, that's very hard. I mean, if you just think about it, I mean, there's so many pictures that are wonderful. I mean, the one I have in the background, it's one of my favorite. It's the cluster Hubble 370, and it's one of the cluster I've been studying during my PhD thesis. So it was back in 1991. So, but that picture was, taken like a few years ago, and it's extremely deep, a bit like the Hubble deep field that was taken earlier on, and it's just impressive. I mean, when I was studying for my PhD, we had this image from Hubble 370, and we could count what we call the multiple image, and there was like, you had to, scrutinize on the ground-based image, and you could count maybe 3 or 4 or 5 multiple image system. I mean, in this image, we have no like more than 40, which means like more than 200 galaxies that are multiply imaged by the cluster. So it's a wealth of information that you get just through these images. It's just amazing. And this is case for studying cluster galaxy, but I mean, like the image of today, I mean, it's just amazing because you can spend hours and days or even weeks just studying this image and trying to understand what you see. It's just amazing.
Yeah, for me also, there are some pictures of galaxies. You see the galaxy, but if you look around, you see so many other smaller galaxies. So the background of any image taken by Hubble shows galaxies in the background. And sometimes in quite a lot of detail, although they're in the background, they are quite detailed. And these results are amazing. For me, again, it's a lot of science, but it's huge emotions also.
Great, amazing. So today we're celebrating 30 years of Hubble. Do you think we'll get to celebrate the 40 years?
I have to say that I have some doubts. It's already amazing that 11 years after the last servicing mission, Hubble is still working so well, because originally when it was deployed in 1990, then first servicing mission in 93, we were always expecting that every 3 to 4 years we need to go and do major repairs. And some of the sensitive elements were the gyroscopes. We exchanged them several times. The batteries also, they are nickel hydrogen batteries, and they have this cycle 16 times per terrestrial day. They go up and down, charge and discharge. And of course, after a few years, batteries say, I have enough of that, I want to stop. So I think either batteries or rate sensor units or these fine gyroscope will at some point die. And Hubble will be something of the past, but a brilliant past. I don't think it will hold another 10 years, but hopefully it's going to be another 5 years at least.
Oh,
at least there will be an overlap with the James Webb.
Yes, exactly. That was actually my next question for Jean-Paul. You've mentioned the James Webb Telescope. So would it be up in time in space until so we can have a direct transmission of work from Hubble to James Webb?
Yeah, that's a bit of the idea, right? When we designed James Webb, the idea was to kind of replace HST. But of course, when you design a telescope, you want to do something different. So it's not exactly the same stuff you can do with Hubble and James Webb. Hubble is, doing observation at UV to near-infrared light. And because when you have to build a telescope, you make compromise, and of course you cannot do everything. So for James Webb, the focus is more to the near-infrared and even mid-infrared quite. So you will not be able to see the UV light in Saturn with James Webb because you will be blind in UV bands. But it'll be very, very good, very, very sensitive in the near-infrared and beyond. And that means you can see things that Hubble has never been able to see. And that's also why it's very interesting to see very early on in the universe the first stars and first galaxies. And that's going to be a complete discovery. People are really waiting for that. But it will be exciting to have both of them at the same time, because maybe James Webb will be able to see some new things that you want to see the counterpart also, let's say, in the UV bands. And only Hubble will be able to do that. So it's going to be exciting, hopefully, during a couple of years when you have both telescopes flying.
Yeah. What we will see, that's the question.
We'll see.
Still open.
Still open, yes.
Okay, great. So now we're going to move to Q&A. So if you want to ask your questions to Jean-Paul and Claude, this is the moment. So I already have a few questions for you. So first one would be, are Hubble pictures in real color, or is it computerized color, meaning with a few exaggeration for the artistic side?
Yeah, so probably I'll take this question. I mean, when you make an image, typically you can make an image with 3 images made of red, green, and blue. That's the standard. When you look at a TV set, you have these red, green, and blue channel. And so depending how luminous your pixel in this red, blue, and green channel are, and that makes an image. And for example, in the case of this nebula that we see in your back, the 30th anniversary image, what we've been using in doing that is what we call narrowband filter. So we have a filter which is very narrow, which is only sensitive basically to the light coming from the oxygen atom or the hydrogen atom. And of course, if you were capable to see with your eyes, it probably won't be such a spectacular, because the blue light wouldn't be so crisp. So there is, of course, always a bit of tweaking of the data, photoshopping of the data. But they're real stuff we are seeing. It's not like we're painting stuff on your data. It's really just enhancing what effectively is detected. And in fact, we're trying to always try to match the color to what will be the closest color that you would see with your eyes. But sometimes it's difficult, especially if you go to the near-infrared data. You're not able to see near-infrared light with your eyes. So you always have to, be some compromise and some tweaking of the data.
Yeah, I remember it's always a great disappointment for the general public when they do astronomy, especially when I was in Calista and they were looking at through the telescope and they were like, oh, I don't see any colors. Where is the nebula? And it's this very little thing, seems to be dust, and it's actually the nebula. And they see Hubble pictures over, and they're like, okay, this is not cool.
Yeah. Well, it's just like enhancing your data. It's not. There's no cheating. I mean, just be trying to make things better.
Nice. But when you, as an astrophysicist, you receive data from Hubble, you don't actually receive only images, you actually receive numbers, right?
Well, the data is a set of numbers of 0 and 1, and then you have to convert the 0 and 1 into something useful. And when Hubble look at the sky, it will look in different bands. So then when you get, to make a nice image, you need to have at least 3 observations of Hubble in different bands, and then you can combine those data and then make a nice color image.
And there's something I would like to say also. We have to recognize the magnificent work done by the Hubble Space Telescope Science Institute in Baltimore, and also the Hubble Space Telescope Control Center in Greenbelt, Maryland, the Goddard Space Flight Center. I mean, these people are professionals. They run the telescope, they provide in Goddard, they provide the data to the Science Institute. Science Institute distributes to the astronomers who have asked for the data, but this is a magnificent team, very professional and very talented. We had the privilege of working with the Goddard people in preparation for the servicing missions, and they were extraordinary people. So behind all these images, we have astronomers, we have the telescope itself, but we have all the people running the telescope and the science, and they are very brilliant people.
Thank you, Claude. Next question is actually for you, from Cyprien Mercier. Do you think they will use one day the soft capture mechanism installed on the last service mission?
Say that again. They will use
the soft capture mechanism.
Ah, okay. Soft capture mechanism. Yeah, okay, that's a good point. Yeah. On the last servicing mission, they installed a soft capture mechanism. As you say, it's a structure in the bottom of the telescope, in the low part of the instrument section of the telescope, the large section. And the idea is the following: when Hubble dies, at some point it will not be used as a telescope anymore because its systems are not functioning, again, batteries or gyroscopes. The idea is not just to let it fall wherever it will choose to go. Right now, it's at about 550 kilometers altitude. Originally, it was at 600, but every servicing mission, we brought it back to 600. But it's slowly coming down. And I don't know exactly what its lifetime is, but probably about 15, 20, 30 years. So it will not be used as a scientific instrument at some point, but it will stay on orbit. And the idea is not to let it fall down wherever it chooses. So the soft capture mechanism is a mechanism that will allow a robot spacecraft to go to Hubble, to dock with it in that soft capture mechanism, and then using the thrusters of this robotic system to do a controlled deorbit in the Pacific Ocean, which is a graveyard for a number of large spacecraft. Small spacecraft, they fall down wherever they choose to. It's not dangerous, but large spacecraft like the Mir space station, that's one example. They are, whenever possible, controlled, deorbited into the Pacific Ocean. That will happen with Hubble also in 10, 20, 30 years from now, we don't know. The robot itself, to my knowledge, is not yet built. But it will be used for sure. We will not let Hubble fall down wherever it chooses to. We will control deorbit it.
Amazing. Next question is for Jean-Paul. Is blue for oxygen? If we look at a picture taken 20 years ago, would it be the same blue for the same molecules?
Yes, in the sense that it's a code we're using. The oxygen blue emission, it's the oxygen 2, which sits at 3727 angstrom. So the very blue part of the spectrum, it's almost UV, it's the start of the UV light. But the color blue, I mean, in the rendering, it might be slightly different, but the coding is always, we tend to use the blue color for the oxygen because, I mean, it's emitted in the blue part of the spectrum. So yes, I would say yes. I mean, the same. Then after, of course, if the Photoshop code is slightly different, then of course it might be looking different. But the signal, I mean, and the emission of the signal and the wavelengths of the signal will be the same.
Okay, great, thank you. This was from Jess Kurt, by the way. And then next question is from Nicole. Are we alone in this universe? So I guess you can maybe both answer.
I personally believe that the universe is full of life. That's my answer.
Okay.
Yeah, I think I tend to agree with Claude. I mean, why, if it's not full of life, you know, it's probably the simplest explanation to why we're here. And well, the life is complex, okay, but it tends to be something relatively easy to develop in the universe. When you have some, you know, basic chemical elements that connect to each other, they will easily produce proteins, and then, you know, you can easily find, you know, a more complex element that will come and become, you know, live. But the difficulty, of course, is, you know, to find this life in the universe, and I think we, as of today, we haven't found any sign of life. We're trying in the solar system by exploration, for example, of Mars, of the Moon, of other planets, of course. We also try to look at exoplanets and looking at the atmosphere of these exoplanets, looking for complex elements that could be detected. Eventually, life could develop into an intelligent, creature like us. And then maybe, those people will be able to send radio signals. So ultimately, we may be able to find radio signal, intelligent radio signal at some point in the universe, but not for today.
Yeah.
We are listening. We are looking and listening.
Yes.
And we are sending signals also sometimes.
Yes.
I was actually secretly hoping that the Hubble 30th anniversary image would be a picture of aliens saying hi to us, but unfortunately it's not the case. Okay, so we have another question from Pinguino72. Do you think the James Webb Telescope will be delayed again?
Well, we don't know. We hope not. But it's a complex machine. I was probably, when I discussed, with the earliest engineer that were behind the making of James Webb, that was back in 1996. And it's project that has been approved, quickly after. And I guess one of the first launch date that was mentioned was probably like 2007. And so, it's been delayed. Of course, 2007 was probably not realistic as a launching date. But maybe 2015 was, something possible. And we've seen, because of the complexity of the system, we have to think of everything that should be working nicely, and because it's going to be deployed in space, really want to make sure that the deployment happen correctly, and that means a lot of testing. And that's the main reason why it's taking time to make sure that everything works.
Nice. And the James Webb is in international collaboration, right? It's not only NASA.
Yeah, it's a NASA-ESA project, a bit like Hubble. In fact, it started with the same kind of sharing, 15% European, 85% NASA. I'm not sure these ratios stay the same because there's been a lot of testing going on, and that was mostly done on the US side. But the launch should be done by Ariane 6, Ariane 5 or Ariane 6?
Ariane 5.
Ariane 5. Mm-hmm. And that's a huge contribution also from Europe. But that's not the only contribution. I mean, we've been working on some instruments. One was completely done at ESA. One was done in partnership with NASA. And I may also forget some other items, Claude, you might know.
Yeah, I don't really know, but I think the Canadian Space Agency is also involved. So this time it's 3 agencies.
Yeah, that's true. Yeah, indeed. Forgot that.
Amazing. Well, so we're coming to an end for the Q&A. And now it's high time to give you the answers to the Hubble quiz. I don't know if Claude and Jean-Paul had the chance to take a look at it, but we'll see if they would have got it right or not. So I'm going to share my screen. It was a fairly easy one. We were nice. Okay. This presentation is so large, it takes so much time to open. Okay. Okay, so how well do you know the Space Telescope Hubble? First answer would be question 1. What year would Hubble put into orbit? So Claude, maybe you know the answer. 1990. Okay, next question. Which shuttle took Hubble into space? So it's a Discovery space shuttle. I don't know if where is it located now, Claude? Maybe you know, in which part of the US can we see this space shuttle?
Discovery is, I think, at the Air and Space Museum in Washington. Respectively, there's a dependence of it close to the Washington Dallas airport, because the Air and Space Museum divided in two. There's a main one downtown, and there is a dependence also close to the airport, and that's where Discovery is. Okay,
great. Question 3, at what altitude is Hubble situated? So 547 kilometers. Actually, my presentation, I said 590 kilometers. It's because the altitude is changing. It's not always constant.
Yeah, I mentioned 600 initially, and now it's about 550. Yeah, that's correct. Yeah.
Question 4, Hubble had a problem on its main mirror, causing blurry images. How big was the aberration? 1/5 of a human hair thickness. That's a big aberration. Question 5, when was Hubble's first repair mission launched? 1997. I wasn't even born. Question 6, how many missions to service and/or repair Hubble were launched? So there were 5 of them, always with the space shuttle. Question 7, how long does it take for Hubble to do one orbit around Earth? 97 minutes. And question number 8, what's the size of Hubble's primary mirror? 2.4 meters. Compared to James Webb main mirror would be
6.5.
6.5. Little player compared to James Webb. Question 9, what's the name of one of the most iconic images Hubble took? Pillars of Creation. So you can see the image right next to it. And question number 10, which space telescope will be Hubble's successor? We've talked about it, James Webb. And also, so talking about this image, I remember I forgot to mention the name of the Hubble 30th anniversary image. We can see in a minute, I hope, if the PowerPoint wants to go. It's called the Cosmic Reef. So I think it's a beautiful name, which goes very well with the image. Okay, well, thank you all for coming. It was a pleasure to have you with us. And we hope you'll be able to come next semester at EPFL to celebrate Hubble Space Telescope in person and to take a look at the exposition we're preparing for with the EPFL library and the Astro. So it was nice to see you all, and see you in space.
Thank you.
Thank you, Chloe. It was
Bye-bye.
great. Thank you very much.
Thanks, Chloe.
Thank you, Jean-Paul.
Thanks, Claude. Bye.